Alright, the law of sines. Law of sines is a way to solve triangles that aren't right triangles. So you don't need to have a 90-degree angle. And it works for certain situations. For example, in this triangle, let's say this is a 50-degree angle, and this side is 5, and this side is 7. So I have angle A and the opposite side, little length A is 7, angle B, its opposite side is 5, and I don't know either angle C or length C, its opposite side. Now I can use the law of sines, and the law of sines is actually really easy to remember. It's simply a ratio, or three different ratios. Length A over the sine of angle A, length B over the sine of angle B, and length C over the sine of angle C. Now, if I can take any two of these and know three of the four things, then I can solve for the fourth. So, for example, in this situation, I know length A, I know length B, and I know angle A. So in my ratios, I know A, I'll be able to find the sine of A, I know length B, and of these two, I can now solve for sine of B, because I know three of the four. So I have to set up my ratio. So length A of 7 over the sine of 50 degrees would equal length B of 5 over the sine of angle B, which I don't know yet. So now I can solve this. So we solve a ratio problem like this by cross multiplying, remembering that sine of B is like a variable. So if this was like an x. So I cross multiply 7 times the sine of B equals 5 times the sine of 50. Right, so now I want to get sine of B by itself. It's multiplied by 7, so to undo that, I'm going to multiply both sides by 1/7. Okay, so these cancel down to a 1, leaving just sine of B. And over here I end up with 5 times the sine of 50 divided by 7. So I now know what the sine of angle B is, but I don't want to know what the sine of it is. I want to know what angle B itself is. So we're going to use inverse sine. If I know the sine, I can use inverse sine to get the angle. So angle B equals the inverse sine of 5 sine of 50 divided by 7. Okay, so now this becomes a calculator problem. Take this 5 times the sine of 50 divided by 7, and then find the inverse sine of that result. Alright, then once we calculate this, I come up with approximately 33.1734 degrees. Okay. Now I've got angle B. So I now know two of the three angles in my triangle. So to get the third angle, I just have to use the fact that there's 180 degrees in a triangle. 50 of them are used up here. 33.1734 are used up here. So I can just subtract those two away from 180 and get this angle. So I'm going to do it this way. I'm going to take 180 minus 50, which is 130. And then I can take 130 minus this angle here. And luckily it's still in my calculator, so I can just do 130 minus the result I had before and come up with angle C being approximately 96.8266 degrees. I now know all three of the angles in the triangle and the two sides that I knew to start with. So the only thing left is to find this length here, little length C. So I need to look at my ratios and find two of them where I know three of the four things. So I still know A and sine of A because I knew those to start with. I now know angle C, so I can find the sine of angle C, and I'm trying to solve for little c. So using these two ratios, I can put those together, solve for little c. So I set it up. I have a of 7 over the sine of 50 degrees equals little c over the sine of angle c, which is 96.8266. Now, one of the beauties of doing this using a calculator is that this should still be in your calculator because it's the last thing we solved for. So I'm going to go ahead and cross multiply here, and then I'll be able to use what I have in my calculator. So I have c times the sine of 50 degrees equals 7 times the sine of 96.8266. I want to get c by itself, so I need to divide through by sine of 50. So c equals 7 times the sine of 96.8266 divided by the sine of 50 degrees. Now remember, we're not solving for an angle, so we're not going to use inverse sine. We only use that when we solve for an angle. So this is now just a straight calculation. This value should still be in your calculator, so you can take the sine of it times 7 and then divide it by the sine of 50. Right, so doing that, we end up with a value of c being approximately 9.0731. Now, just to do a quick check, here we had angle B is approximately 33 degrees, and angle C is approximately 97 degrees. So if length C is approximately 9, so our shortest side of 5 should be across from our smallest angle. Our middle side of 7 should be across from our middle size angle, and our largest side 9 should be across from our largest angle. So just glancing at that, this appears to all make sense.